Good evening, everyone. Today we're going to go over electron valence shells and the geometry of those shells and how to visualize them. What we're going to use are balloons, and we're just going to tie the balloons together. So, atoms are bonded together with electron pairs in each valence orbital. All electrons are negatively charged, and so they repel one another. And when they are bonded, they tend to have that repelling effect on other valence orbitals. So, just like the knot here in the balloon, we have an atom, and that central atom has these electron shells. So these pairs of electrons make these shells, and so they push against one another, forcing it into a specific shape. This specific shape is a linear shape. Now, that is not the only type of geometry that you can have. You can also have three pairs. And these three pairs, like in sulfur dioxide, would have three domains. But with sulfur dioxide, you would also have a lone pair. Now, a lone pair would sit somewhere up here, pushing against the atom as well. If you have two, they are going to be opposite of one another and repelling one another kind of in the same fashion that the valence shells themselves do. Now, the type molecule for that would be an AB2, and the electron geometry for sulfur dioxide would be triagonal planar. So a triagonal planar. Now, the next one we're going to look at is ammonia. And I define my little ammonia example. And as you can see here, we have 1, 2, 3, 4. So there's 4. So 3 here, 4. This is a tetrahedron. Tetrahedral. And when the tetrahedral is an ammonia molecule, you're going to have, of course, 4 electron domains. We're going to have an AB3 as well, lone pair of 1. So we have one lone pair, because it's probably going to be somewhere right here above the atom. Now the next one that we have is going to be our 5th one, or our one with 5 domains rather, and that is called a triagonal bipyramidal. This one, I guess the best way to look at this is, see, we have 4 on this plane, and then 1 up here, creating 5. So 4 and 5. Now that's an example of that would be chlorine trifluoride. That's 5 electric domains. AB3 is going to be the type molecule, and triagonal bipyramidal. But the difference between this and our other examples is it will have 2 lone pairs. And those 2 lone pairs will push against one another. We've talked about that before. They'll be set opposing one another. That same repelling factor. Now, the last one that we're going to go over is one with 6 total domains. This example is xenon tetrafluoride. And as you can see here, you have a very similar to the 5. You have the 4 on one plane, the 5, but with this one, you have 6. So you have 1, 2, and then 4, so 6. This would be AB4 for the specific example that we are going over, the xenon tetrafluoride. This would be considered a octahedral. It also will have a lone pair of 2. So once again, I'm going to look at that plane 4, 5, and 6. And those are all of the different electron geometry. And that's going to be it for tonight. I appreciate you watching and tuning in, and hopefully we'll see you next week.